Hi, my name is Jan. I'm a freelance software architect, and I've been recently doing a lot of two things. One is using domain-driven design to make sure that we're building the right systems, and one is using the ZEO framework to make sure that we're building those systems in the right way. Let me ask you first, have any of you used domain-driven design before? Oh, a couple, that's nice. Have any of you used the ZEO framework? Any other effects framework? Okay. Oh, we have a nice balance there. So I will give you, time is limited. I'll give you a very rough idea of some of the patterns that we use in domain-driven design to help model businesses and systems and people involved in those. And for this presentation, I asked a friend of mine called Stable Diffusion to help create pictures of some of these things because they can be a little abstract. So let's look at one of the concepts we know in domain-driven design called a bounded context. What we try to express here is the idea that if you're in a big company, say 500 people or more, these tend to divide themselves into certain business areas, and even if you don't do anything, they grow into these silo-like structures of people that work together because of their assignments, but also prefer to work together in their own ways. As you can see here, you get sort of domed off areas that are nice on the inside, but people don't like to cross over the wasteland to some of the other places. And if you have to build systems to support that, it can actually be a good thing because you're sort of isolated to one silo. The reality, though, is that this didn't come out of nowhere. This business grew. And what you don't see in this picture is that underneath there's actually one big system that tries to facilitate all of these silos. And when it rains, it all turns to a big bowl of mud, which you might have heard before. So while you're building a system, be aware of the areas in which the people interacting with your system come from. And it's okay to say, okay, we're only looking at this part of our business at the moment, and we can ignore these other things. Or maybe if we don't, if we find out, well, this particular financial department talks a lot to sales there because they have this additional link, maybe you have some stakeholders over there that you actually need to pull in, and the context doesn't span just your department, but it might include other people as well. If we look a little bit more deep into such a context, another pattern that we find is from domain-driven design is called ubiquitous language. Let me just ask you, who of you knows the term role for initiative? Yeah, a couple. So that's from a role-playing game called Dungeons and Dragons, and that's a very specific thing that means something to the people here that are trying to play that game as well. But it means nothing outside of that. And it's similar with the computer systems that we are building, where you introduce concepts and names like an account, a user, a service, a dependency even, a customer. What that means for you might be, is that a case class customer? Is that what sales is actually talking to as a customer? Is that an actual person that is standing on the doorstep and walks into your company? What do we mean precisely by what a customer is? Now, what ubiquitous language teaches us is that what we should try and do is within such a bounded context, as we are talking to business people, actual customers of our system, and other stakeholders, a language will develop. Like we talk about these things that we handle in our system, the customer, the account, and whatever else we may come across. And we should pull those words into our system and use those as the actual words in our source code. This might sound obvious, but as a developer, you often have this idea, yeah, they're calling it a customer, but I know we have some other people as well. I'm going to call it person, because that's a better name. Or we have like these trams and buses we just saw. I'm going to call that vehicle, because that obviously that's the combination of a tram and a bus. It might be, and it might not be relevant, but maybe the people that, now in this case, you might not actually know the tram and bus system, But if you can talk to the people actually having trams and buses, maybe they do have a word for that. That might be a better fit without having to introduce semantic overhead. And we actually had a nice discussion yesterday as well on what if you're not in an English-speaking domain? Finance and pensions and insurance are quite well known for having in non-English countries like Denmark, where I'm from, or Poland here, very specific terms that exist in the law in that country that might not have a proper English equivalent. And it's totally okay to just use that word in your source code, because you're not going to find a better one. Just use whatever makes sense there. Now, as you're talking from one system to another system, you inevitably have to exchange some situation. Maybe you handle invoices, and you get the invoices from some place, maybe you process them and send them to some other place. And that other bounded context, which might be within your firm, it might be some other service that you interact with, they might not have the same idea on what an invoice is. They might even call it something else. Maybe they call it a document. Similarly, if you need to get person data, they might have different names for these things. An anti-corruption layer is a part of your system, or sometimes an entire system, that helps you align your vocabulary, your granularity, the way that you interact with your data, with some external dependency in such a way that you don't risk exposing the rest of your system and as a side effect, the people using those systems to the words and vocabulary of some service that you depend on. And again, this is something that many developers have done naturally, like, oh yeah, I build an interface, abstract away from that. Sure. But to me, it was a very nice realization that there is actually a larger effect of building that abstraction, and being explicit about that can give you added value also in the other way, like, hey, should we use those terms that they use, or should we use our own? There are some really interesting discussions to be had there, like on the quality of the naming of things that you come across in your systems. A final pattern that's actually often overlooked is published language, which from domain-driven design says, hey, if we now actually do have some business domain that we are working with here, like maybe we're dealing with contact data of people that use our products. Maybe we're handling invoices. Maybe we're handling appointments. Like, oh, we're using Scala. We can model this, right? Create a nice ADT of, an invoice has this and this and these things in there. It's very quick, yeah. But is that a good idea? Because people have done invoices before. They've modeled this, and similarly for contact data, people have built data models for people and for appointments before. Like for contact data, there's VCal. For invoices, there's a thing called UBL. For appointments, there's iCal. So when you're dealing with data, try and take that extra step and see, okay, is there like a standard or some published meta model or something in XML or JSON or whatever makes sense that we can already use? And because it will give you two advantages. One is that you're not going to miss any things that you haven't seen yet, the mysterious unknown unknowns. Like, who of you have ever received an invoice? Yeah? Well, you think, okay, I know what an invoice is. It has some invoice. We'll be talking about invoices more. That's why I'm sort of picking it out. Like, oh, it has invoice lines and this, and that's all right. So I can make a system for invoices. Yeah. No, it's not that simple, because many countries in the world have weird and wonderful laws around finance and these things. And you're going to miss out if you don't look at what standards already give you. And contact data and appointments is a similar thing if you've ever traveled across a time zone, as you may know. So let's talk a little bit about the system, which will be our use case for today. So the customer the client I was working with had a brilliant idea. Let's just to introduce them a little bit. They are a fairly big international company operating in 150 countries that have a lot of suppliers in each country sending them invoices. And they wanted to streamline that process and figured, well, let's find a cloud invoicing service, put all our stuff there, because then it will be nice and neat and sit together, and we can do data and machine learning and all sorts of fun things. If we sketch out that architecture a little bit, you see our cloud service and the suppliers to the left, then our magical integration layer, and then different countries to the right, because one reason for running this project was actually that the individual countries have different systems to handle their finances today, because they rarely interact with each other. They have different flows. There are some reuse of products, but they very much have customizations as well. So how many bounded contexts do you think we have in this picture? I might have overstepped a little bit already in asking the invoice question before, but the supplier has one way of sending invoices toward the cloud service, but they probably have their own little process. So there's definitely a bounded context there. Well, this we haven't built yet, so let's skip over that. Now, all the countries have their own processes, so already knew that. So there's actually a lot of separation to be done here, and this might be a little bit more complex, or there might be some side effects on modeling this if we want to make this a success. Now, luckily, there exists a standard for invoices and related business documents called the Universal Business Language, or UBL. And one thing that it does is it has really looked internationally at, okay, what do actual larger companies, what practices do they have if we look semantically at the contents of purchase-related documents, like invoices and orders, but also purchase receipt advices when stuff gets sent, and everything related to that. One example is that if you invoice somebody and you made a mistake, you can't just send the invoice again because, laws. You have to send something called a credit note instead that says, oh, by the way, you don't have to pay this part, or you don't have to pay it at all. And that is a completely different flow, yet many systems, for one reason or the other, have modeled that as the same thing. Because they both have lines with values on them, even they have a very different business meaning. UBL decided to separate out those, but we'll see those again. Now, for the system that we are building, without looking much at the cloud service that we're integrating with, one thing that we decided was, okay, let's make this as accessible as possible for the different countries to find out what data is there to fetch, what new invoices are there for us. And one decision that was made was, okay, let's have a REST API, because that is typically fairly simple to consume. But let's make this event-based so that countries can have a polling API or some of the technologies that you see here to simply say, okay, are there any new invoices for me? And just by sending a GET request, they can either say, they get a response, okay, no, there's nothing yet, or they will get whatever new invoices there are. And internally, we'll use Kafka as a storage, so that we'll figure out some way or the other to talk to our cloud service. Maybe they have a similar API, maybe they don't, but at least we will be able to get the data that we need. And if we ever need to change that or fidget with that's okay. We'll have this nice and easy to understand API towards the countries, where each individual invoice here will actually be XML that is UBL. So there's a standard there that's a published language. So they will be able to make up what that invoice is without much interaction with us. Now, the client already preferred Scala for this because they had a team working with that, at least at that point. We started with Akka because me and the other people on that team had some experience with that. Although about one year in or so, Zio became more well-known, Zio 1 at that point. And I actually decided to start seeing, okay, how would it look if we started to write some of our stuff in Zio? And had very positive experiences there. So we've basically written everything over in Zio now, except for our HTTP server. And that was actually before Akka's license changed. So there's some clairvoyancy going on, or I don't know. But it all worked out pretty nice. I will say a little bit about Zio as well, yeah, since many of you have seen it before, we'll skip over the net. What I really noticed was that if you look at Scala as a language, it's not profiled as being better than Java, but it is. It gives you a lot of ways to express safety, especially in your type system, that you don't get from Java. And I had that experience when I first started out with Scala, way back. But I have had a similar thing starting with the Zio framework, where I've experimented with other effect-based things, but this was the first time I sort of saw a lot of good ideas click together, and they sort of compressed that into one item where, yeah, you can do all of those things separately with other frameworks, but having it together makes it sort of easy to do the right thing and harder to shoot yourself in the foot. And that's kind of stuck with me. So if we look at what Zio gives you, Zio is a data type, so you can create instances of it. And a instance of a Zio is a description of something that if you kick it and make it run by giving it the environment that it needs, it will eventually give you either a value or an error. That's expressed by the 3 type parameters we see here, the R for the environment, an error type, and a result type. So you can sort of think of it as a function that takes an instance of R and then asynchronously gives you something back. Except it's not a function, but it's a value, which is very useful because if we have an instance of Zio, it's actually not running yet. If you've ever used futures, if you have a handle to a future, it's already on the way, and you can no longer choose not to do anything with it. One interesting thing for the environment, which I guess starting out with Zio, I kind of looked at the environment, was like, okay, this is a strange thing. Why do we have this? I just want to, give me my value. It's asynchronous, nice. But there's actually a lot of very, very powerful and not that complicated things you can do with it. And one good example is the scope concept that was introduced in Zio 2, where if you have a Zio that has scope in its environment, so that's a dependency, so you need an instance of scope to run, that actually indicates that Zio can hold on to some resource and is required to release it again at the end of its runtime. And the scope instance helps it do that, because that scope has to have been created by somebody that promises to then release it again after that Zio has run to completion. So it gives you a safe way to handle resources like open threads or database connections, or maybe a background process that you have to run for a limited amount of time. We also have streams in Zio, which, similar to what was just explained, a stream actually has the same 3 type arguments, except in a stream we emit multiple values. That's basically the only change. Where Zio will just finish just once, a stream can finish or give you a value more than once, or give you an error more than once, and every time something happens there, you can catch the error and do something else, or say, well, no, we're done with that. And it being a stream, you can do interesting things. We've seen a couple of operators here just in the previous presentation, but one I just want to point out is taking in the time aspect of streams with this grouped within operator. I'm sure FS2 has something similar as well. But when we say a stream emits multiple values, they of course do that at a certain time. And because we know when that time is, and everything runs asynchronously, and we have schedulers and things to help out here, you can actually have an operator that says, hey, I want to group up to 5 elements, but if a second has passed by and I haven't gotten enough elements yet, I still want to emit them, which is extremely useful for these buffering kind of operations where you want to collect as much data as you can, but not more than this, because it doesn't fit in memory, but I also don't want to be too slow, so I don't want to wait for all of them, and do a nice computation with that. That's extremely useful. I will have to skip over this. So, we started out using our cloud invoice service, and this is what a typical day at their department must look like, because if we use their API, and they have an API, REST API, we ask them, well, does this country have any new invoices? They go in and do stuff for about 10 seconds, and then they say, no. And you ask again, because we're polling, are there any new invoices? And then they again sit for 10 seconds. It's kind of slow. Similarly, there's this way where customers can select stuff from lists of customer-specific things, and you can add values to that. It's like a key value store. I'm not sure how many of you know the Redis response time, but it's probably under 1 millisecond, if I had to guess. Well, they take a good second to store a new value, which they're kind of slow, especially if you have 10,000 of these values to store, because, you know, big countries, lots of suppliers, lots of orders. And our first interaction with that API went something like this. Okay, it's kind of slow to have 1 second per request. Well, we have this nice asynchronous framework. We'll do what anybody would do. We'll just set more of them at the same time. I think 400 would be reasonable. So let's do that. And their server crashed, which led to a very interesting communication in first explaining what a concurrent TCP connection is. Like, you might actually get more requests at the same time. I said, no, please don't send more than 16. I'm not sure 16 was the actual number. It might have been less. And curiously enough, just about a month later, there mysteriously was a new feature in the API, which was that they now rate limit the number of requests that you can send them. But given that our parallelization was done through ZIO Stream, there's actually a nice operator that we can use, which is called map ZIO par unordered. It's a little bit of a mouthful, but it tells you that we're mapping each element in the stream onto a ZIO again, because we're doing an asynchronous call to our cloud service. We're doing that in parallel, which means that we can do multiple things at once. And unordered means we don't have to get our elements back in the same order. So whatever comes first, it's allowed to already inject that into the next stream. And that was all we had to do, because this operator is there. Just one simple change to sort of make them happy again. Similarly, at a later point, we realized that is still somewhat simplistic. We wanted to have a bit more control over what we're actually sending them, especially because, you know, if you're dealing with a service with this performance characteristics to that many countries that are going to use it, it's probably a good idea to have a lot of metrics that say, okay, we're precisely using you like this, because there's bound to be disagreements on performance and things. So we actually decided to write our own little rate limiter to put in between the requests we send to them and the stuff we actually send out, which again turned out to be not that complicated in ZIO, because you have these nice building blocks, very safe building blocks that you can use to put that together. One thing to touch on that is one of the niceties is another thing that you might find in the environment of a ZIO instance, which is called clock. Clock is a ZIO service that allows you to get the current time, just like system current time millis, except this thing indicates now that you have a ZIO or a Z stream that actually does something with time. And time is a funny thing. If you could obviously just use system time millis, and it will just current time millis, and it will work just fine until you start to write a unit test. If you have written unit tests for things that work on real time, before ZIO there were these things like, okay, you configure your load balancer or your bucket thing to do something, and then wait for 1 millisecond in your test, or wait 1 second, because then you're sure that the thing has actually continued past what it has to do. With ZIO, clock is a part of their testing framework, and if you have ZIO that uses clock, you just start it, and you say in your test, pretend that 1 second has happened, and then ZIO does sort of the stuff that it needs to do to make sure that everything that was waiting for that 1 second has actually finished executing, and then your test continues, which means anything that uses real time, you sort of read through your code and say, oh, do this, wait 1 second, do that, wait 1 second, but it doesn't actually wait 1 second. It runs through immediately and concurrently with everything else. So your tests become predictable and fast, even though you're using actual time in your code. Another thing we came across was some creation API for some callback objects that you can create to indicate the state of an invoice. Or there's an API that's where you can, like a post request, post/objects. Here, create this thing for us. And then they come back with your typical post response, 302 created, here's the ID of your object, go and use it. Oh, we go and use it, we update the object, here we're done. And they say, 404, I don't know this object. And they do this under high load, like once per week or a couple times per week. And again, after a lot of digging, there comes this response, yeah, we have something with MySQL replication, and you might be reading from a slave because we didn't, we didn't actually replicate it to the slave yet, and you might have hit that, yeah, tough luck, can you retry your request? We're not gonna fix our system. Well, retrying, we're using Zio. We have this line update object status, which returns a Zio instance. Well, Zio has a method, .retry. Remember how we talked about that a Zio instance is just a value? It is not running yet. So you can actually take that value and change it in some way and say, well, I want, instead of just this Zio that if kicked will call the service, I want a Zio that will kick the service, and if that fails, kick it again, and maybe does that a couple of times, waiting some smart exponential backoff in between up to a maximum, and then fail. And all you have to say is just .retry. It's very useful. I'm not sure how many of you have built invoicing systems, but given the context that we're in, how long do you think it would take to return an invoice that has 100 lines in it? Anyone over 10 seconds? Over 1 minute? That's 2 minutes, because that makes sense. I've actually worked as an invoicing startup. 100 lines is not a lot. 10,000 lines starts to get into the area of bigger invoices, but this is not crazy. Still, but we obviously can't change it, we can't affect it, but 2 minutes is way past a reasonable length for an HTTP request, so some proxies might get unhappy during that. So we want to do a bit more here because invoices are kind of important, and we want to know that we tried to get it and didn't actually get it. So here, if the invoice fails, we want to write an error into some special log that we have for that, and then retry. And since .retry is the last thing there, it will actually retry the whole thing, since it operates on the last value. Now, that event log itself is just a Kafka topic that we write stuff to in a JSON format. But like all developers, we try to introduce some bugs into our software, and in this case, I think it's JSON for S or some other JSON framework, don't quite remember. But you had to be fairly specific in what subtypes of a class you can serialize or deserialize. And either way, we released something where that didn't quite add up, which means that if you wrote to the journal, that actually failed. But the system still kept running, because we declared this log method that writes something to the journal. Kafka's client, Kafka.produceString, is declared as a Zio that, when it succeeds, gives unit, but when it fails, it will give you, I think, a Kafka exception or something that encompasses the error. And in Zio, just if you have either, you have to handle that error. You can't just ignore it. You will get compile errors if you don't make that error go away somewhere by either saying .ignore everything, which you typically don't do, or by something like catch all or map error or something that requires you to deal with it. And that, because you had to do that when writing this code, okay, let's log something into our event journal, we had to make a decision. How do we deal with that? What do we do with this error? Well, in this case, we know we're writing just to a log entry, so let's ignore the error. That's a conscious choice you would make there, but we were forced to make that choice while writing the code because we had this error handling. If it was just a Java exception, it would probably have disappeared and have crashed when we actually fetched an invoice because we couldn't write to the log. So these, in this case, we were quite happy that we were forced to handle errors in that sense. So what we've seen is that our system, starting off just as a anti-corruption layer for the invoicing concept by introducing UBL, we actually are able to shield away from a lot of other mistakes as well. I wanted to show one final thing, which has something to do with Zio, but not so much with the rest of the talk. The nice green diagram that you saw has actually been created using a little application I've been building on Zio on the client in the web browser, where you can make little diagrams and move stuff around, which of course in a demo it doesn't. You can make some things here. If you are at all interested in Zio or in client-side Scala, please get into contact, because it's a lot of fun. I was pleasantly surprised how far you can actually push a fairly complex framework like Zio that still operates really well on a web browser as well. Thank you.
All right, thank you, Jan.